Article 100 of the National Electrical Code defines an outlet as a point in the wiring system at which current is taken to supply utilization equipment. A remote panel in a detached building serves as a distribution point, not a point where current is directly supplied to utilization equipment. Therefore, it doesn't meet the code definition of an outlet. Think of an outlet as the place where you plug in a lamp, an appliance, or other electrical equipment. It's the final point of connection between the building's wiring system and the device that uses electricity. A panel board, on the other hand, is a distribution point. It receives electrical power from the service equipment and then distributes that power to various branch circuits. These branch circuits, in turn, supply power to outlets and other electrical loads. To understand why a remote panel is not considered an outlet, it is important to consider the complete electrical system in a building. The service equipment, which is usually located near where the power enters the building, provides the main disconnect and overcurrent protection for the entire electrical system. From the service equipment, feeders are run to panel boards located throughout the building. These panel boards then distribute power to branch circuits, which supply outlets and other loads. The definition of an outlet in Article 100 is specific and intended to differentiate between the point of supply for utilization equipment and other components of the wiring system. The purpose of this distinction is to ensure that electrical installations are performed safely and in accordance with the code. For example, the code has different requirements for the spacing of receptacles along walls in dwelling units to ensure that cords from lamps and appliances can reach an outlet without creating a hazard. These requirements would not be applicable to a panel board, which is not intended to serve as a point of supply for utilization equipment. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association and is widely adopted by states and municipalities throughout the United States. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, electrical engineers, and building inspectors to be familiar with the code in order to ensure that electrical installations are performed safely and in accordance with the law. Article 100 of the NEC contains definitions of terms used throughout the code. These definitions are essential for understanding the code's requirements and for ensuring that electrical installations are performed correctly. Some other important definitions in Article 100 include the following. Firstly, accessible readily, which means capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. Secondly, appliance, which means utilization equipment, generally other than industrial, normally built in standardized sizes or types and installed or connected as a unit to perform one or more functions such as clothes washing, air conditioning, food mixing, deep frying, and so forth. Thirdly, branch circuit, which means the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Fourthly, circuit breaker, which means a device designed to open and close the circuit by non-automatic means and to open the circuit automatically on a predetermined overcurrent without damage to itself when properly applied within its rating. Fifthly, conductor, which means a material, usually in the form of a wire, cable, or busbar, suitable for carrying electric current. Sixthly, dwelling unit, which means a single unit, providing complete and independent living facilities for one or more persons, including permanent provisions for living, sleeping, cooking, and sanitation. Seventhly, equipment, which means a general term, including material, fittings, devices, appliances, luminaires, apparatus, and the like used as part of or in connection with an electrical installation. Eighthly, feeder, which means all circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit overcurrent device. Ninthly, grounding conductor, which means a conductor used to connect equipment or the grounded circuit of a wiring system to a grounding electrode or electrodes. Tenthly, overcurrent, which means any current in excess of the rated current of equipment or the ampacity of a conductor. It may result from overload, short circuit, or ground fault. And 11thly, service equipment, which means the necessary equipment, usually consisting of a circuit breaker or switch and fuses, and their accessories connected to the load end of service conductors to a building or other structure, or an otherwise designated area such as a park. Understanding these definitions is essential for interpreting the requirements of the NEC and for ensuring that electrical installations are performed safely and in accordance with the code. The NEC is a complex and comprehensive document, and it is important to consult with a qualified electrician or electrical engineer if you have any questions about its requirements. The proper application of these definitions ensures consistent understanding and safe electrical practices. For instance, knowing the difference between a feeder and a branch circuit is vital for selecting the correct conductor size and overcurrent protection. Similarly, understanding the requirements for grounding conductors is essential for preventing electrical shock hazards. The electrical code is a living document that is constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the code in order to ensure that electrical installations are performed safely and in accordance with the law. The National Fire Protection Association offers a variety of resources to help people stay informed about the NEC, including training courses, publications, and online forums. Electricians and electrical engineers are required to have continuing education, which often involves staying up to date with the NEC. It is the responsibility of anyone involved in electrical work to familiarize themselves with the code and to follow its requirements carefully. This is to ensure the safety of people and property. The National Electrical Code, or NEC, is a comprehensive set of guidelines and regulations for safe electrical installations. It is published by the National Fire Protection Association, or NFPA, and updated every 3 years. The NEC is widely adopted by states and local jurisdictions in the United States, and it serves as the foundation for electrical safety standards. The purpose of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The code is based on sound engineering principles and reflects the latest research and best practices in electrical safety. The NEC is a complex and detailed document, and it is essential for electricians, electrical engineers, and building inspectors to be familiar with its requirements. The code is constantly evolving to reflect new technologies and changing conditions. It is important to stay up to date on the latest changes to the code in order to ensure that electrical installations are performed safely and in accordance with the law. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical safety, such as wiring methods, grounding, or overcurrent protection. Each article covers a more specific topic within a chapter, such as the installation of specific types of equipment. Each section provides detailed requirements for a specific aspect of electrical installation. The NEC is written in a clear and concise style, but it can be challenging to understand without a solid foundation in electrical theory and practice. It is important to consult with a qualified electrician or electrical engineer if you have any questions about the code's requirements. The NEC is not a substitute for good engineering judgment. It is important to consider the specific conditions of each electrical installation and to apply the code requirements in a way that ensures safety. The NEC is a valuable resource for anyone involved in electrical work. It provides a comprehensive set of guidelines and regulations for safe electrical installations. By following the code's requirements, you can help protect people and property from electrical hazards. In addition to the NEC, there are other electrical safety standards that may be applicable to specific types of electrical installations. These standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, or Underwriters Laboratories, or all. It is important to be aware of all applicable electrical safety standards and to follow their requirements carefully. Electrical safety is a shared responsibility. Electricians, electrical engineers, building inspectors, and homeowners all have a role to play in ensuring that electrical installations are performed safely and in accordance with the law. By working together, we can help prevent electrical hazards and protect people and property from harm. proper understanding of the electrical code relies on understanding the definitions of the terms involved.